Here in northern Arizona, for hundreds of miles surrounding the bridge site at Marble Canyon, the country is rugged and mountainous. Trails lead to many historic places, large petrified forests, balanced rocks, and hogans of the Navajo Indians. Marble Canyon, cutting the country in half, derives its name from the fine-grade marble of its walls, 600 feet apart at the top and reaching down 500 feet to the Colorado River below. Here, a deck arch type of bridge was considered most economical. Many obstacles had to be overcome in delivering materials to this site. Steel was delivered to the rail-headed flagstaff, and special trucks were required to transport to the bridge site 140 miles away. It was thought possible to transport lighter members across the canyon by smaller trucks, and an attempt was made to do so. Here we see how light beams, made as short as possible, were lashed to the side of this small truck, and the trial haul was started over the Mormon Dugway, a narrow one-way mountain road. The trail, as you can see, was very rough and crooked, with steep grades, deep gullies, and no bridges. This long, winding, tortuous road led down to the bank of the Colorado River. Crossing the river at Lee's Ferry, however, proved impractical. A few days after this scene was taken, the ferry was wrecked, and this method of transporting the smaller steel members had to be abandoned. "75 miles of new roads had to be built to accommodate these special trucks. In making the 140-mile haul from Flagstaff to the bridge site, the trucks traveled almost continuously day and night. It required 29 hours to make the round trip. Steel comes to the job ready for construction. Every member is a unit with a definite position in the structure and can be placed without delay. With foundations completed, the work of erecting begins. As we watch the sure-footed workers tackle their jobs, the compactness of structural steel becomes apparent. Thousands of rivet holes match corresponding holes in adjoining parts with such precision that rivets are inserted without any further preparation. Stresses have been computed exactly, even to the stress in each individual rivet. Steel members are clearly marked for their place on the job, are identified and sorted for the erecting crews. In order to control the fitting of the center hinge pin of the arch, large diamond-shaped jacks or toggles are introduced at each end of the bridge. These jacks have a capacity of 700 tons each and will be operated when the center pin is placed. Stationary engines that will operate these jacks now supply power for the booms on the Traveler. The steel is rolled out on dollies and is swung by the booms out over the canyon. With the lower cords projecting out into space, sections begin to take form. As steel follows steel with clock-like precision, we get a new understanding of the steel worker and the material that he handles. To the lay mind, it seems like putting together a giant puzzle, but it is not a puzzle to the steel fabricator or engineer. Nor is there any puzzle in the steel itself. Every process in making steel, from its refinement to the final passing through the rolls, is supervised and safeguarded to maintain uniform quality. The erection of the steel frame proceeds more rapidly than any other type of fire-resisting construction. Cold weather will not delay it, and the hottest summer temperature will not affect it. Regardless of weather conditions, steel construction proceeds from the Arctic to the equator. Progress in erection is marked by the advance of the Traveler. The Traveler works by setting the farthest filling-in pieces in a panel first. Building nearer itself until the last piece is set, it is then moved forward. Unmindful of the ever-present danger that lurks in a misstep when aloft, the steel worker depends upon his sense of balance as he goes about his job, giving little thought to great height or the river below. He takes it all in his stride. Exposure to the brilliant Arizona sunshine made the task of the steel erector something to write home about. We know of men bundling up for protection against extreme cold, but here's one for Ripley. During summer, these men actually had to don heavy underwear, thick gloves, and stout shoes to protect them from sunburn and the heat of steel. Here we have an example of temperature high enough to scorch the human foot through the leather sole of an ordinary shoe, with the work of erection proceeding uninterrupted and the efficiency of the material unaltered, proving that it is practical to build anywhere, anytime, with steel. Riveting crews follow closely in the wake of pinning and bolting, with perfect timing between the red-hot rivet tossed and the riveter's bucket. As the steel of the structure projects farther out into the space of upper air, the loads on the steel anchors become greater and greater. With the erection of the first half of the arch completed, the traveler is dismantled preparatory to its transportation and erection on the opposite side. While this work was going on, a man out on the traveler boom was able to throw a bolt attached to 300 feet of stout cord across to the other side. To this was attached a wire, and to the wire a cable. And by this simple method, transportation for men and materials across the canyon was established. In erecting the first half of the arch, all materials and supplies were transferred from the storage yard to the erectors by dollies. In erecting the second half, all men, materials, and necessities had to be transported by cableway. Greatest of all necessities in this land of golden sunshine is water, and plenty of it, as the size of this drinking water container attests. Keeping the cableway lubricated combines the talents of the steel worker and the circus acrobat. We have seen these steel members transported over rough mountain roads, and now we see them carried over a great natural barrier. They require no freighting or special carriage. Construction being dependent upon the traveler, no time is lost in its reassembly and erection. From across the deep gorge now comes the great shoe, and the work of erecting the second half of the arch gets underway. Here we see the steel anchors and how they are secured in rock tunnels, 125 feet long, with each anchor capable of holding 1,000 tons. The sun shining on one side of the bridge in the morning and the other side in the afternoon subjected not only the men to extreme heat, but the steel as well. Structural steel maintains its strength to a remarkable degree in the presence of atmospheric heat. Investigations have shown that it actually increases in compressive strength with a rise in temperature. Careful calculations are made throughout the entire construction of the bridge. Over 30 triangulation readings were taken in order to determine the exact location of the shoes. Temperature expansion of the anchor steel lowered the location of the center pin 3.5 inches daily, and the effects of the sun's rays would move it up or downstream as much as 3 inches. These changes were carefully taken into account, especially so when preparing to place the center hinge pin. The toggles controlling the center hinge of the arch are now operated while the pin is put in place. One must be impressed by the comparatively small number of men who, with simple machinery, have handled and erected the many steel members that form the bridge. The Navajo Indians paid for these high, closely latticed railings we see being erected as a protection for their herds of sheep goats in crossing. The length of the arch span is 608 feet. The total length of the bridge with approaches is 832 feet, with the bridge floor 500 feet above the water. Thus, in spanning the Colorado River at Marble Canyon, steel has made another contribution to the advancement of civilization.